Hi everyone, this is Pooty. Today we are going to talk about thread programming in Java. Before introducing the thread concept, we were unable to run more than one task parallelly. It was a drawback. Hence, to overcome this drawback, thread concept was introduced. In this video, we will be learning about what is thread, life cycle of thread, advantages and disadvantages of thread concept, and then thread priorities demonstration. We use thread concept in Java to perform complicated tasks in the background. The program runs more efficiently when threads are implemented as it allows multiple tasks to be executed at the same time. All the tasks are executed without affecting the main program. In a program, all the tasks have their own separate paths of execution, so each thread is independent. A thread is a very lightweight process, or we can say the smallest part of the process that allows a program to operate more efficiently by running multiple tasks simultaneously. Another benefit of using thread is that if a thread gets an exception or an error at the same time of its execution, it doesn't affect the execution of the other threads. Life cycle of thread in Java is basically straight transition of a thread that starts from its birth and ends on its death. So let us understand how to identify thread states in Java thread lifecycle. A thread is a path of execution in the program that goes through the following states. The five states are as follows: new, runnable, running, blocked, and dead. The first state in the thread lifecycle is the new state. In this state, when the thread is created, it is in new state. New implies that thread object has been created but it has not yet started. At this point, thread is considered to be not alive. It is the state before the start method is invoked. The next state is runnable state. In this state, a thread is ready to run and is moved to runnable state. A thread might actually be running or it might be ready to run at any instance of time. It is the responsibility of the thread scheduler to give the thread time to run. The next state is running state. In this state, a thread is in running state when it requires to start execution. Then it is known as active thread. Based on the situation, the next possible state is block state. In this state, the thread may be entered into block state by using suspend, sleep, or wait method. A thread is in block state when its execution is temporarily suspended. The final state is dead state. In this state, a thread is in dead state when its execution is completely or forcefully stopped. Then this is done by using stop method. Now let us consider a real-time example of a music player. The moment you tap on the button to play the audio, a thread is created and you see the thread starts proceeding and your song starts to play. From the runnable state, it enters the running state and it keeps on running till the song is not finished. Hence, that is like terminated state. In in case in between, you just go for the pause. That's where the thread is going to do the wait operation. So when your song is automatically finished or you just stop the song, that is the terminated state. So this is how the thread works. Let us go through few advantages of thread. Enhanced performance by decreased development time, simplified and streamlined program coding, improvised UI responsiveness, simultaneous and parallelized occurrence of tasks, better use of cache storage by utilization of resources, decreased cost of maintenance and better use of CPU resources. These are the few disadvantages of thread: complex debugging and testing process, overhead switching of context, increased potential for deadlock occurrence, increased difficulty level in writing a program, and unpredictable results. Now, let us go through an example program to demonstrate thread priorities. In this program, we have created three classes named as class A, class B, and class C, with each class extending the thread class. All the three classes perform the same task, which is to print a string in a for loop. In our main method, we have created three objects named T1, T2, and T3 from class A, class B, and class C respectively. For each thread, we have set different priorities. As you can see, For T3, we have set the maximum priority, which is 10, and for T2, it has been set as 5. And for T1, it has been set the minimum priority. When the start method is called based on priorities assigned, the T3 has the maximum priority, hence it will be executed first, and T1 has been assigned the minimum priority, hence it is executed last.
Enough of theory now, let's get our hands dirty. This is Shreyas, here to talk about creating our first thread, different methods available in threads, and thread synchronization. Before we create our first thread, let us first understand that there are two ways to create a thread. One is by extending our class with thread class, and the other way is by implementing runnable interface to our class. In this example, I have created a class named extendThread which extends the thread class. In our main function, I have called the start method which changes the state of the thread from new to runnable. When the start method is called, the thread switches to runnable and hence the run method is called, which is overridden from the parent class. In this method, we are printing two strings. As explained earlier, our class extends the main thread. In our main method, we have called the start method on our thread, but when we run our code, we can clearly see that the main method has been called first and then the thread string has been printed. Now, let us see another method to create a thread. This example is quite similar to the previous type of thread, but here we are implementing the runnable interface. The only difference is, while we create a thread, we first create an object of the runnable interface, which is used to create the thread object. The rest of the working is similar. As we have earlier discussed, our class implements the runnable interface. Here, before we create our thread, we must first create an object of the runnable interface. In our main method, we are creating a thread by using the runnable interface object. As you can observe, there is a print statement below our start method, but you might expect these two strings to be printed first followed by this, but when you run the code, you can clearly observe that this string has been printed first followed by the other two strings. One of the most used methods in thread is the sleep method. We can put the thread to sleep for a set amount of milliseconds using the sleep method. In this example, I have used the sleep method with 2 seconds, which is 2000 milliseconds. You can also observe that I have wrapped the sleep method with try catch block. This is because the sleep method throws an interrupted exception when there is an error. In this example, I will be demonstrating the thread sleep method. As you can observe, I have implemented the sleep method with 2000 milliseconds. This says that the thread will be in sleep mode for 2 seconds. Let us run the code and see the result. As you can observe, the start of thread has been printed here along with 2 seconds of delay, and then print after 2 seconds has been printed. Let us check it again. The thread class provides few methods to create and operate threads. One of them, as we earlier discussed, is sleep method, which is used to put the thread to sleep for a set number of milliseconds. Each thread is assigned with a unique ID. We can view this ID using the getID method. The thread's name can be user defined, which can be changed using the setName method. And to view the assigned name, we can use the getName method. Every thread has priorities where we can set the priority to a thread using the setPriority method. And to view the priority, we can use the getPriority method. There is another method to get the current state of the thread by using the getState method. There are many other methods which are more important, but right now let us keep it more simple. We will be going through these methods. In this example, I will be demonstrating a few methods as I have discussed earlier. Here I have created a class named thread_methods which extends the thread class. In our main function, I have created an object of the thread, and using the getState method, I am printing the state of the thread, which is new. Using the setName method, I have named the thread as thread1. As I've called the start method, the state of the thread changes from new to runnable, hence the run method is called. Here, using the getName and getID functions, I will be printing the name of the thread and its ID. Using the sleep method, I have put the thread to sleep for 2000 milliseconds, which is 2 seconds. As you can observe, I have wrapped the sleep method with try catch, as there are chances of interrupted exception being raised. In this example, I will be demonstrating most of the important methods in threads. Here you can see I have created an object of the thread class. Using the getState method, we will be printing the state of the thread. Using the setName method, I will be setting the thread name as thread1. We will be calling the start method, which changes the state of the thread from new to runnable. Hence, the run method is called. Here, using the getName method and the getID method, I will be getting the name and the ID which is set to the thread. You can also see I have implemented the sleep method, which puts the thread to sleep for 2000 milliseconds, which is 2 seconds. Synchronization in Java is the ability to share a common resource with multiple threads. Here, I have created two threads named mythread1 and mythread2, which both extends thread class. There's another class named table, which prints the multiple of n into I for 5 times. In our main method, there are three objects which I have created from each of these classes, named object obj, t1 and t2. Both the threads T1 and T2 are being started. Since I've used synchronized keyword for the print table method in our table class, the resource is being shared evenly. That is, first T1 gets to use the function, later the T2 thread is being used. In this example, I will be demonstrating the synchronization of threads. Here I have two classes named mythread1 and mythread2, which both extends thread class. I have another class named table, which has a method named printTable. You can observe that there is a synchronized keyword which is used to help the synchronization of this class. In our main method, there are three objects which are created from three classes respectively. We call the start method on our T1 and T2 threads. Let us run our code and see the output. This is the final output of our synchronization thread program.